This is Algebra 1, lesson number 10, and in this lesson we're going to look at multiple representations of functions, and we're going to do something really fun. We're going to look at function machines, and these are from Polypad, which is now part of Desmos Classroom, but I think these are great. It's a good way and a fun way for kids to look at multiple representations in a fun way. So we'll start with slides, and then we'll do a Desmos activity, which will be the bulk of this lesson. And that one's really domain and range and context. So we'll be looking at graphs and equations, restricting the domain. And then finally, we'll do a quick activity in GeoGebra, writing equations of lines. So the first thing they're going to do in their slides is go to this screen, and they're going to click on the link, and it says click for function machine 1. Follow the instructions and paste a picture of your completed work on this slide. So they will click here and it will take them to Polypad. Now this is already kind of set up for them, and their instructions are labeled first, second, third, fourth, last, so they should follow along. I would start by not giving them, oh, and then close this, by the way. So let's see if I can get this closed. Forget how I did it. Yeah, you can close that if they want to just get it out of the way. They're going to drag these into the function machine. I usually just let them try to do it on their own first and don't really say much to them. I just let them follow the instructions. They always have the option of going back to the slide and getting the link and starting over if they make a mess of it, and like if they weren't really reading the instructions and they kind of did something. I don't think they can break it, but you know, I've said that before and they found a way to break it. But anyway, this is what they're doing. They're putting these numbers into this function machine. It makes a cute little sound when they do, so you might tell them to mute if they're all doing it at once. It's going to drive you nuts. The second thing it says to do is click on the function machine and then tabulate. So they're going to click here, and then they're going to click the word tabulate. And that will create a table of solutions for this function. So the goal is to try to figure out, well, what is an equation for this function? Well, to help them, they can create a graph. Now, it does have scatter plot. I wish it would just graph a line, but that's not an option. Or maybe it is, and I just don't know what I'm doing. But click on scatter plot, and it will plot the points that they have put in their table. And then they can use that to try to help them come up with an equation. Now, I wouldn't tell them this right off the bat, but they could use a Desmos graph calculator to check their answer and type it in and see if it's coming out with these values. They can create a table and basically duplicate this table in Desmos if it's, and they'll see if it's right or not. So that's something you may consider telling them if they're struggling, but then they'll write the equation. I'm not going to put the equation up because, well, I want them to know, so I'm not going to put the answer here, but in the teacher slide deck, I'll have all the answers. And then once they have this done, they're going to export the image, or they're going to just screenshot it. And honestly, screenshotting is probably easier. They can just take a picture of this right side. They don't have to get the instructions in there if they don't want to. Here's where they export, and it would download it to their device, and then they would upload it to their slide deck and put it here. So the next thing we're going to do is function machine 2. So they have another one. They'll follow the same instructions. Now when you get to function machine 3, I've actually given them one of their new parent functions. We're about to get into learning the other parent functions besides linear. We already know y equals x, or f of x equals x. So we're going to add to our little collection here. And I'm not going to say what it is, but they should be able to figure out what it is by putting numbers in. I'll put it in the teacher show notes if you can't figure it out. And then for number 4, same thing, and for number 5. So all of these, they are going to play. I would give them a minimum, I don't know, 20 minutes, 30 minutes. It kind of depends on your group. If you've got a group that's pretty strong and remembers their 8th grade mathematics really well, they may fly through this. But if you have a group that's not and doesn't remember how to write the equation of a line, for example, or is not noticing these patterns, the graph's not helpful, then you may spend a little bit longer. And then, of course, if they're still stuck, Desmos calculator to the rescue. And finally, on these parent functions, you can tell them if you want to. We are going to be telling them in the next few assignments what the parent functions are. So if you have to, you have to. But our goal is to get the kids to do these independently or with their teams. After you finish with your slide deck, we'll move on to the Desmos activity. The Desmos activity is domain and range and context. So we have actually covered this before, and we're going to get even deeper into it. We're going to put it together with our discrete and continuous and evaluating functions. So this is just loaded up with all kinds of review, and we're putting it together, and real world context, all of the above. So they will evaluate a function, they will solve to find a value of an X value or an input value, and then they will tell what it means in a context. Be sure to read the teacher notes on these because they are fairly extensive. They will fill out a table to match this scenario. They will choose a graph, whether it be discrete or continuous, which one makes sense and why. I wrote a lot of notes down here in teacher moves. So on this slide, I think this is the first slide, I gave some sample responses and teacher moves. Look at those for hints on how to address this with kids without just saying it directly. I would not mention discrete and continuous yet because it's coming on the next slide. I would see if you can get the kids to say discrete or continuous here. If they'll say it, that's fantastic. That's what we want. But I wouldn't tell them yet. Let's wait and let them ponder it a little while. I would restrict access to future screens because they will go get these answers and not learn it as well. So we want them to kind of think about it a little longer, and then you can open up access to the next screen when everybody's had a chance to do that. And then once they choose an answer, the one they chose will be the only one that shows up here. And then you might keep mentioning up here tickets at the county fair. It may not help at this point because this is kind of a new thing for them, but eventually we hope it will make sense because we're going to remind them here on slide 6. So if they didn't catch it before slide 6, then on slide 6 you're telling them directly, oh yeah, remember discrete data is when we count things, distinct points, not connected. And then the continuous graph are when we measure things. And so you can remind them of the activity they just did, I think two lessons back. And then they can go back. So on here I suggested review these measurable, countable, and that's when they need to go back to slides 4, 5, and 6 and just make sure they have it. We were talking about tickets, ticket sales. These are discrete, distinct points. You don't have fractions of tickets, so you would not include the points in between in this scenario. And then they have another scenario, and this time evaluating a function, solving. And same thing, they're going to make a table, they're going to choose a graph, they're going to basically, it'll choose the graph and it won't display but the one they chose, and then they'll choose 2 answers to represent. You may consider putting up the dashboard in your classroom and changing it to anonymize so the child's name's not displayed, but they can keep up with their work while they're doing this, and that way they'll know if it's correct. That's up to you. It depends on what I'm doing. If I really want them to think about it a while, I won't do that because then they'll just click till they see that check mark, and I don't like that. But every once in a while, especially when they're doing some skill practice that's a little tedious, I might put it up there so they can check their work. And here's another one. And then again, compare the domains. Explain how the domain relates to the graph. So, the input values, the number of tickets. Why would we use positive integers? And they could talk about that. You would use positive integers because you're counting the number of tickets. For the domain in this scenario, though, it's the number of hours. And you can have partial hours, a fraction of an hour. You can include all the fractions in between these whole numbers. And so something like that. And then the range, domain and range, go back to the same two scenarios and describe the range. What is it? Where is it in the graph? What does it represent? Why would you only choose these numbers for range and not the numbers in between? And so on. And then this one, they are not going to use all the cards. You might want to point that out. It does tell them there will be 3 cards remaining you do not match. So as much as we hope they read the instructions, we know some kids are going to totally skip over that. So do remind them that they will not use all the cards. They will start with the scenario. It tells them to start there, and then they will find the other cards that fit it, and they will leave 3 unused, which means 1 graph won't be used because you can't be both of these. All right, and then if you don't get it, it's going to tell them. If they do get it, this little turns into a smiley face, so they'll go back until they get that one right. So it is self-checking. Now this one, they're writing an equation for a function. I did put starters in these blanks. They do have a graphing calculator if they need it to help. This one, they're restricting the domain, so I've kind of started it for them. I will not always do this, by the way, so this is going to go away in future lessons, but I'm still giving them the format so they can get a hang of it. So they'll simply type in numbers for those 2 question marks. And then we did the same thing for the range. So unlike the last time we did this, I think I used a Y. I changed it to D of X for distance traveled. And that's the name of our function. And then here is the fun part. They are going to create a discrete function for a real life scenario. So they only have a few in this activity. So you might have a conversation with the class. What are some more things that we talked about in our earlier lesson? You could even pull it back up. One reason I love Google Classroom, and I always use that to push out my assignments, is that if a kid wanted to go back and look at a previous assignment and view it again and think about it again, they could. So in this case, they could go back to that assignment where we went to the website and looked at all these different examples of discrete and continuous data, and they could go look at some of the discrete data in that assignment and maybe use one of those or something similar for their own scenario here. This activity, this particular screen in this activity would be eligible for their portfolio because they are creating something unique for themselves. So they will need a graph and they will have a list. I did not ask for an equation for the discrete function, so they don't have to write an equation, but they do need to make a domain and a range list of the numbers, and I basically showed them how that could look. And then they're going to do a continuous function, again, a real-world scenario, real-world context, and I did show them how to type their domains, and they do need to put that in the blank with their equation. So they will put it down here, and then they're going to sketch a graph over here of it. So they will actually probably use the line tool. I'm assuming they're going to give me linear data. Let's hope so, because they would have probably struggle if they tried to do a different one, since we haven't done that yet. But they do have the graphing calculator. I would encourage them to use, they can guess and check and try different things to see what it's going to look like. And then again, they can use this in their portfolio as well because it's something they created themselves. Now, the next activity in the assignment will be GeoGebra. So the last activity we're doing today is a GeoGebra activity, and they are writing equations of lines. The beauty of this task is they will have the ability to use any form they want for this linear equation. As long as it's equivalent, it will say correct. So I'm going to intentionally not use slope-intercept, although that is the obvious choice here, just to show you what happens if they don't. So the first thing I would note is that the slope, if you show the hint, it will show the slope triangle, is 1 over 3, because it's going up 1, right 3. And then I'm going to use this point right here. It looks like it's -3, -6. So to go left 3, I'm going to do x plus 3, and then I'm going to go down 6. And then when I click notice, it said correct, but look at what it gave me. It gave me the equivalent slope-intercept form of that line. So encourage your kids to be creative if they can be. You know, if you can give me another way to write that, just that's awesome. If they want to do slope intercept every single time, that's also fine. But just let them know they need to do at least 5 of these, and they will paste their completed screenshots. They'll screenshot the correct and they'll put it in their slides. Now, I know your kids would never do this, but mine will copy other people's work. They will take their photos and they will send them around to their friends, and so you'll have 10 friends with the same exact slides. So you have to be on lookout for that. It's bound to happen. I'm just saying, just letting you know. But you know, the kids that take advantage of this, it's a fun little quick exercise, and hopefully they get these right away. Now, as soon as they finish one problem, they click here to start a new one. They can show the hint to show their slope triangle. This is going down 1 space and it's going right 4 spaces. So we'd use -1/4. They can use the y-intercept, which is 0, -3, and they can put it in slope intercept form. One thing I do by accident a lot is I click new problem before I give it a chance to say correct. What you want to do is click out of this blank over here, and when you do, it'll say correct. So let's just do this one to show. Y equals -1/4, -1 divided by 4. And then I'm going to use the slope intercept form this time, -3. And then click here, and then it'll say correct. So don't click new problem, because it'll delete that problem. Click out onto this blue part, and it'll say correct if it is correct. So this concludes our function machines, multiple representations of functions lesson. I hope y'all enjoy these function machines. They're so much fun. And I'll tell you what, PolyPad is full of so many cool things. So I encourage you to get in there and play around and take a look. Check their YouTube channel because they've got all kinds of videos showing how to use these tools. Y'all have a great day.